Hello, in this video, we're gonna set up a basic main loop. I only got one file, main cpp, and this file we're gonna use for testing. Now the first thing I'm gonna do is go to linker system and change from console to Windows application. We're gonna get rid of that and that. So the way the user of the framework is gonna use it is by including first off our framework. So also I need to note that I've called it dosen. You may call yours however you like, of course, it's just a silly name I came up with. So the user is gonna include this in here, and then you're gonna write some game init code here, then they're gonna define some game update logic, right? So game update code, and some game destroy code, and that's it. And the framework is gonna manage the loop and everything. So let's create the first file, which will be dosen.h, and this is kind of our hub, the main file of the include file of our game framework. Here we're gonna include windows.h first and foremost. Oh yeah, by the way, we're not gonna have this int main because it's Win32 application, and we're gonna have to use something else, so it will look like this: dosen, something like entry point. Okay, and so it's gonna be a macro. Let's define it: dosen entry point. So here I've written down int win API win main. So this is the entry point of our application. This has to be that way. It has to be win main, and it has to have these arguments. Also, it's not going to be dosen entry point, but dosen app entry point. I think it's better that way. So a dosen application entry point, and what the preprocessor does is instead of this, it will paste this code here. It's just a wrapper because I think this looks rather ugly. This looks a bit nicer. And basically this is it. We've got a Win32 API. For example, if we say message box caption, and you type so hello, title, or window title, window text, I think can be okay, and in here just 0. By the way, if you're confused why we're using those L's, this L here says that this string is actually white string, so it has Unicode encoding. Let's run this, and here we've got window text, window title. I got them mixed up, but that's okay. Okay, so this is a Win32 program. Okay, so next we're gonna include in here window that we're gonna include game.h, and we're gonna create that file game.h, and we're gonna also, it's gonna be a separate translation unit, so game.cpp. In here pragma once we're gonna have a namespace reducing okay, we're gonna have a class game. Okay, private first let's put this in here. Yeah, okay, let's include those needed here. So we're gonna here declare a window callback function. So a window callback is a Win32 API specific function. That's why it looks like that, it looks weird. And we're gonna say that it's a friend function. This means that window callback function is not a method of a class. It's a separate function outside of this game class, but in this function, within this function, we can actually access private members of game class. Okay. Next we're gonna have an let me see, H instance, this thing here. Now this is specific to Win32 API. Then H, I think it's that handle, window handle, and let's initialize it to 0, and then boolean running, and it equals to false. And then we also need we'll include string, and we're gonna have std w string title. It's a w string title, so it's a white string Unicode string. That's all it is. So title, then we're gonna have int window width. Okay, title probably should do window title, right? Window width and window height. So these have to do with window, game window, and then we're also gonna include functional std function weight float delta update. This variable will contain user-defined game update function, which we're gonna invoke on each game update within our game loop. This is basically our public section, and in here we're gonna define in CPP, we're gonna define a constructor. This here says basically that we cannot make a copy of a game object, because in our program we only need one game object, so we're gonna make it a singleton. And in here we have a static variable game, and a static variable means that it's a variable that exists throughout the life of our program. It's always there, but it's local to this function, and we're gonna use it to access our single game object. If you don't really get singletons, don't worry about it. And it's more or less just for convenience, just for our API, our game frameworks API to look nicer, in my opinion. But don't worry about it if you don't completely get it. As we go on, I'm sure at some point you'll gain understanding of it. So next we're going to define static void start. So start for our game, and since it's gonna be a pretty simple function, we're gonna define it in here as well, but later. I guess let's call them inline. Doesn't really matter, but inline static void set window properties const std string w string title w string title const int window let's do just width and const int height. So const and reference here just makes sure that we don't make a copy when we pass those parameters. It doesn't really matter. We could simply do something like that. That would be fine. But just for, I don't know, that just kind of feels better. Okay, window. So here we're gonna use get instance for our instance, because this is a static function, right? So this function does not belong to a certain object, game object. We're gonna get an instance of our singleton instance, and then window title and just title, and the same for the rest of those. Width, window width, and for height. So set game update. Here we use this is function the user will use to set the game update logic. As you can see, it takes update function, and this is simply setters. And now let's create getters for window properties. So these are window title, these are the getters, and then we're gonna have a private function void start window, which we'll define later in CPP. So now let's go to our CPP file, include game.h, namespace using, in here game. So we're gonna give get instance, no, not get instance, window title. So here let's pass some using app. Let's do this. Window title, window width. Let's do 2080, and window height 720. Okay, next we're gonna define this function, a friend function, window callback. So let's actually comment this. Init window properties to default values. And this function, window callback, handles window events. So it returns our result. We're gonna have some sort of result. If everything was processed correctly, it's gonna return 0 as a result. So let's create 0 as a result, then switch. And so as you can see, it takes window handle. Actually, let's call it window handle like so. No snake case. I'm gonna use camel case. And so we take a message, and based on that message, so there are different messages that tell you what event has occurred. So I think it's VM close, WM close. So WM close says that, oh, the window has been closed. Now let's do output debug string window close. Now we also are gonna have default. So we're gonna handle some window events, but some of them we're not gonna handle, and those that we're not gonna handle, we're gonna pass them to default window procedure and window message. Those events that we're not gonna handle, we're gonna pass to a default, to the default window procedure. Okay, so WM close happens when we press X to close the window of our game application. When that happens, we're gonna get instance and set running to false. Okay, get instance. Okay, also there is one called WM destroy. So the close happens when we close our window. Destroy happens when the program exits. Normally it will never be called. Also there is WM paint and window paint, and this event occurs, well, when after our window initializes the first time, and this is when graphics get painted to the window, right? And also when we resize our window, it will also this event will occur. and this basically means that we need to output something fresh, some fresh graphics to the window. We have a paint struct, we create a device context, and we so in begin and end paint is where we draw, and we're just gonna fill a rectangle. This rectangle is the whole of the window, and yeah, and we're gonna fill it with some color. I'm not sure which one it will give, but we'll see. Okay, so this is pretty much all for window callback for now. In the future, we're gonna handle like user keyboard input and mouse input. So yeah, this is the function where we're gonna do all that, but for now this will suffice. Now let's create a void game start window. First off, const wchrt lookout window class name. So we have to create a window class, and it has to have some name. Let's call it deucen window. Don't forget to put L. This is a pointer. Now let's create a wind class. Window class, and empty initialization means that all the members of this function are gonna be initialized to the default value, and we're gonna actually initialize some of the values ourselves. For example, window class.style. So style, if you don't know what these things, this is basically a boilerplate code. Don't even remember what exactly this means. Let's check. You can just simply Google it like that, and here is docs.microsoft.com, window class styles. Let's see what this one means. Redraws the entire window if a movement or size adjustment changes the width of client area, and then v redraws the entire if a movement or size adjustment changes the height of the client area. Oh, the height and the width. Now window procedure is our window callback. H instance is our H instance, which we have in here, and then class name is gonna be this class name. Now we have to register this window class pointer. If not, returns 0, right? This means it failed. So let's see out what string failed to register window class, and L, and we just return straight up. Okay, remember we had a window handle in here, so this is where we use it. So we create window X, and there are a bunch of different values that we have to provide. CW use default, for example, is where we want the position of the window, the X and Y position of the window, where it's gonna appear, and we just use default values. Here we provide a class name, this we have to do, and here we provide a title window title for our title bar. We use cstring. We convert it to cstring, obviously, and these here are the size of our window, and we use h instance. All the other values are 0. That's it. If you want to know more about this function, just copy this and go. Actually, maybe I can even look for it here. Yeah, on docs, create window function, and here they're all specified if you need to go in depth. Now, if we have our window handle, so it can successfully create a window handle, and then our window handle is gonna have some value, otherwise it's gonna have 0, in which case we can simply output something akin to this file to create a window. Don't even need this anymore. And if it did successfully create a window, first off, let's output something like, so this is inside of this if statement we're gonna specify our main game loop. So here let's just say game init, something like that. Let's set running to true, and while running, so this is our main loop. So we're gonna process window messages. What window messages are basically events. So here we have a temporary variable message, peak message. So we go through every message, we take in the message, we remove it from the queue. So you can think of it as an event queue. We've got a bunch of events, they're called messages in Win32 API, but they're a bunch of events, and we so in one frame a bunch of events happened. We take each event one by one. If our event type is WM quit, we just stop running. It means that our program wants to quit. Otherwise, we're gonna translate the message, and then we're gonna dispatch the message. And what dispatch message means is that we send message to window procedure, which is our window callback. So as you can remember, here we've specified that our window procedure is going to be window callback. So this message is going to be dispatched, and it's going to appear in here in this window callback. And here is going to be our message, and here we're going to handle it. So that's pretty simple. So we process windows messages, window events, and then here we do update and render. And here we're gonna do get instance dot update, and we're just gonna here we're gonna invoke our user-defined game update logic. Also, we need to pass delta. Let's pass in 0 for now, and let's see how it works. Now I also said that we were gonna define start here. We're gonna define it as instance get instance dot start window. Simple as that. Let's go to our main. So here we write some game init code. Now here we write some game update code. We're gonna do it like that. Using game set game update, and we're gonna provide it with a function. Okay, so here we define our update logic. First off, let's do out debug string, and let's just do my game. Let's do just game update. So on each frame, we're gonna simply output game update. By the way, I don't know if I mentioned this or not, but the reason why we're using output debug string and not something like stdcout is because, well, we've changed this project to Windows application, right? And in Windows application we don't have a console. We just got a window. So for now we're outputting to this output here, to debug output. Okay, let's see how that works. Nothing happens. For some reason nothing happened. Oh, because we haven't started the game. Juice and game start. Oh, okay. Now let's start it up. Okay. So it seems to work. We have game in it, we have window paint. Let's close this. We've got window close, but for some reason it didn't output our string. Why? Oh, it messed up a bit. We need to put this in our loop, of course, our main game loop. Sorry. Yeah, now it prints out update. Hey, let's do so. Okay, now it works properly and it outputs game update, the string on each frame. So the only thing left to do is to actually have some delta time handling, so to be able to tell how much time one frame took, and we'll pass it in this update function here. Okay, so first off, we need to initialize the clock. First we get the CPU frequency by using query performance frequency function, which returns the amount of counts our CPU can go through per 1 second. Then we initialize our last counter with query performance counter, and it just returns a timestamp at that moment that we initialize it. Okay, then in the loop we need to query. So this is the last counter. Now we get the current counter. We initialize that. Okay, then we see how many counts have elapsed between the kind of current time and the last time we took measurement, and based on that, so we take how many counts have elapsed and divided by how many counts our CPU can go through per second. And in that way we get delta in seconds. Okay, then we set the last counter to the current counter, and basically now we have the delta. So let's press it in here. Okay, that's great. And now we can actually go into our main, and let's actually in here output how many our delta, just output our delta, wchar char buffer 256 as print sw printf. So because we're gonna use output debug string, we first need to create a char buffer and put the data in there, because we can't use printf, so we have to use a char buffer and sw printf. I keep forgetting that we're following the common case. So char buffer 256 delta f, I think, and then delta. So it doesn't like something, probably no. And output debug string char buffer. Okay, and now it outputs delta in seconds. So this each frame right now takes 0.00006 seconds. Okay. So that's great, and that's it. Now we have window initializing, we have a basic main game loop, and we have delta handling too. So the next video will deal with 2D graphics. So yeah, that's it. Bye.